Hi everyone, welcome back to our channel. Today we are going to find the solution for the below problem. Find the equivalent resistance between R, AC and find the total current drawn by the network. Let us try to see how to solve this problem. You can see here this above is connected in an delta. So I'm going to convert this delta into an star. So before converting, first mark the nodes as A, B as well as D. So this is like a delta, then automatically you're going to get the star with neutral and another star. So these are the three elements we are going to get across A, B, D. So you may get quite doubt how to find this center resistor. Okay, so this you have to find. You can see here this black color resistor is connected to two red color resistor. So therefore the formula is 5 into 5 divided by 5 plus 5 plus 5. So whenever you are going to solve it, you are going to get it as 1.66 ohms. So the same formula we are employing. This black color resistor is connected between two red. So the formula is product of 5 into 5 divided by sum of remaining is nothing but 1 5 plus 5 plus 5 5 plus 5 plus 5. Here you are going to get 1.66 ohms. So this resistor also same formula we are going to get 1.66 ohm. You may get doubt. The no need to do directly like this rigorous calculation. So the upper one is an delta, you require an star one. So just by one formula, this is nothing but, so this is like star, we need to convert the delta to a star. When you convert the delta to star, just divide the values by 3. So just by using your calculator, verify the value. 5 divided by 3, the same answer we are going to get. Okay. So that is the formula behind the conversion of a given delta with equal resistance can be converted into star, just multiplying each branch resistance by 1 by 3 times. So now successfully got it. So now we are going to continue the problem. So here we have the AC and here we are going to have the remaining two resistors. This value is 2 ohm and this value is 3 ohm. So when you see it, you can understand that again when you see the problem, the current starts flowing and current will flow like this, and these two branches are connected in series. Again this 1.66, the current starts flowing and current flows like this, and I can say these two resistors are also connected in series. So now I'm going to redraw the diagram. So at A, we are going to have only one resistor. So at A, we are having only one resistor. The value of it is 1.66 ohms, and we are reaching a neutral point. And you can see these two are connected in series. So whenever they are connected in series, this is nothing but sum of resistors. Therefore, you are going to get one branch here, and you are going to get the another branch here. Okay, so this is nothing but the C point. So this is nothing but the end point. So 2 plus 1.66, we are going to get it as 3.66 ohms. So this is 3 and this is 1. We are going to get it as 4.66 ohms connected across the terminals are AC. First we need to find out this one. After drawing it, you can see here these two are again connected in parallel. Okay, so whenever they are connected in parallel, then you are going to have A here, and here we are going to have 1.66 ohms connected at neutral and connected at C. So when these two are in parallel, then again we are going to get a single resistor. So the formula here is 3.66 into 4. 3.66 divided product of resistance divided by some 3.66 plus 4.66. If you solve it, then you are going to get this value as 2 ohms. So again, you can see the diagram. These two are again, current starts flowing in 1.66 and same current flows in 2 ohm. I can say these are again connected in series connection. Whenever they are connected in series connection, then just but sum of these two resistors. Then 2 plus 1.66, which is 3.66 ohms. So this is across RAC. This is A node, this is C node. This is nothing but RAC, and I want the current in this one. So, and we are applying an voltage of 2 volts. Okay, so we are going to apply voltage of 2 volts. Therefore, current I is equal to V by R. So, what is the current? What is the voltage at this point is 2 volts. The voltage at this point is 0 volts. 2 volts minus 0 volts divided by R. Okay, so when you perform it, then you are going to get the current as by 3.7, then you are going to get the current as 0.54 amperes. So this is how we are successful in finding out R AC, and the solution is 0.54. It's simple to understand. It's no need to hamper your brain. Convert the given delta to and star. These two are in series, these two are in series, then you'll get two branches. Again, these two are in parallel, then you'll get one more resistor. Okay, so when you get the one more resistor, automatically those are connected in series with this resistor, then you are going to get it as 0.54. Hope you are able to understand the video. So if you feel the content is useful, subscribe to the channel, give a like, and subscribe to this channel with the name KV Tulsiram. We'll meet in the next video. Thank you for watching.